My name is Nate Crenshaw, and this is the drink mixing machine by Team 9. To start, we're going to review a couple of foundational topics like the mission statement, the concept generation, customer profile, and the schedule. The mission statement overviews the whole product. We have our target market identified as Virginia Tech students, our benefit proposition as our 1 cubic foot product that customers will enjoy, and it can be stored easily. All of our stakeholders are the manufacturers, the sellers, the people who sell beverages that will go into our machine, and our customers. So we utilized a Gantt chart to stay on track. Most of the time before Thanksgiving break was spent doing assignments, but afterwards we did a lot of building and ended up with a product that works today. We imagined a student as the target customer for our case and developed a use case for it. The use case is pretty simple. It just involves selecting the drink and having it be poured. From this, we gave surveys to customers or potential customers that helped us develop our needs. We found that the process should be quick, it should be clean, and the product should be easy to store, as well as the cleaning be easier than normal. Our product specifications were then ranked based on the QFD. We found that the quality or the filling accuracy was the highest requested, as well as the liquid flow rate being high. Our functional decomposition for our product is that we input beverages, electricity, and user input to create mixed drinks, create light energy and pump energy for operation, and display recipes. From this, we generated a bunch of concepts based on 3 categories: data storage, liquid selection, and liquid storage. The Arduino has an internal EEPROM that can store only 2 kilobits of data, which is not enough to store all of the cocktails recognized by the IBA. We iterated between the methods of liquid selection and the amount of tanks that we have. And from that, we generated 8 product concepts. These are all combinations of what we just described. And this is the result from our gallery method. We ended up going with concept 7, the one with external EEPROM, 4 tanks, and 4 tubes with valves that connect them. From that, we created a CAD model, which looks like this. There are 4 tanks in here: selector, the pump, Arduino, and the outlet. We found a bunch of patents for products that overlap with ours. The aspects that overlap are reservoir pumps generating the pressure, the tubing that is designed to support thicker syrups, similar housing and four-tank design. We did a failure mode and effect analysis where 3 failure modes were identified and 3 solutions were identified for them too. One is a tank holder that secures the base of each tank so it's harder for them to spill. The other is a seated liquid collection tank or thing for the pump and selector if any of the lines fail. And the last one is a liquid collection tray for the tanks if they get overfilled. We created a design for assembly based on what we actually did. And in total, we estimated that the time taken is about 640 seconds or 11 minutes. The actual time that it took was about an hour with all of the parts available. With this, we estimated the learning curve, and the time to assemble the first unit was the same, and we estimated a parameter of 0.85. This in the limit goes to about 174 seconds, which is about 3 minutes and 15 seconds. Or, no, it's about 3 minutes. At our break-even number of products, we estimated that it would cost someone working $15 an hour at this product making rate to, it would take 28 and a half hours to make the number of units, which is 458, and it would cost about $430 for them to do it. We created a bill of materials based on, by researching different sellers of different products that we use in our design. And we came up with a total cost of about $73. This included the voltage regulator, wall outlet plug, all of the bolts and nuts that we use for the pump and other things, plywood, stepper motors, the EEPROM, and the Arduino. The final CAD designs were generated from our customer needs and functional decomposition. I based these designs on peristaltic pumps that are already on the market. And the casing was designed based on similar products on the market. Our final design is pretty similar to our CAD models. It doesn't have all the rounded corners and stuff, but it looks like this, and there's all of the electronics seated inside of it. So our product can be improved based on the FMEA analysis and customer interviews, which we would conduct after distributing our product. All right, thank you.